Okay, this is part 2 of the Ask the Protein, and this part is called Turning Proteins On and Off. It's not enough for a cell's protein to be folded correctly and sent to the right places. The cell also needs the right amount of each protein. If it just kept making more and more copies of any given protein, it would completely use up many of its raw materials. It's like the difference between burning the right amount of wood in your fireplace and burning down the whole house. Also, if there were even one protein that the cell could not stop making after it had made enough, that cell would be it would be soon. I'll read this to you again here. Also, if there were even one protein that the cell could not stop making after it had made enough, that cell would soon be jammed so full of that protein that it would die. The production of every individual protein, therefore, must be turned on and off at just the right moment. Even if a first cell had just popped up with all the right amounts of the correct proteins perfectly folded in the right place to begin life, it would have had to replace each protein as soon as it wore out. If the cell knew when and how to make the first replacement protein, it would have drowned itself in copies of that protein unless a control system were already in place to turn the production off when it had made enough. One of the most important methods of turning protein production on or off is by means of regulatory DNA sequences. They are stretches of DNA whose job is to tell the cell when to start and stop the production of each specific protein. The DNA, however, cannot turn protein production on or off by itself. It works together with specialized proteins, each which fits a particular stretch of regulatory DNA. The regulatory protein folds perfectly so it will fit the exact spot on the DNA with which it must work. Together they form a switch. Neither the regulatory DNA sequences nor the regulatory proteins will work without the other. Both must have come into being perfectly coordinated by the time production of the first protein needed to be turned on or off. Proteins are so complex that they will not form anywhere in nature except in cells where the directions for the construction are already contained in the DNA. Then, if a protein is to perform its task, its production must be carefully regulated. But even when regulated properly, it will not function unless it also has the correct address tag and is properly folded. All these systems would have to have been in place before the first cell could live and function. These systems, however, are just the tip of the iceberg. I chose them to illustrate the many coordinated systems that would have to have been present before the first cell would work. The teaching that the first cell was spontaneously generated without the involvement of the creator has its basis in the pre-scientific myth that single-celled creatures were simple. It obviously does not stand up under today's knowledge that a cell's DNA, RNA, membranes, and proteins are extremely hard to make, and when made, they must be properly folded, addressed, and turned on and off at just the right times. None of these brilliant solutions could invent itself, yet no first cell could exist without all of them. They could not have happened without a very intelligent creator. The Lord's solution to these complex problems were, in fact, comparably better than those which are now hoped for from the world's most powerful supercomputer, from the world's most super powerful supercomputer. Yeah, from the world's most powerful supercomputer. They remind us of how powerful and intelligent God is. We can trust Him with our lives. Let's do that. And that was by Thomas F. Hines. Did God create life? Ask a protein. Look it up on the internet. Okay? Bye.